Welcome to this comprehensive guide on C-sharp delegates, a fundamental concept for building flexible and extensible applications in both Visual Studio and Unity 3D. Delegates in C-sharp are powerful, acting as type-safe function pointers that allow methods to be passed as arguments, assigned to variables, and called dynamically. They are essential for implementing callbacks, handling events, and creating modular applications, making your code more adaptable and maintainable. At their core, delegates are reference type variables that store references to methods, much like an object variable stores a reference to an object. They enforce type safety by requiring a specific signature, including the return type and parameters, ensuring only compatible methods can be assigned. All delegates are derived from the system delegate class, providing a common foundation for their functionality. Declaring a delegate involves using the delegate keyword, followed by the return type, the delegate's name, and its parameters. This example defines my delegate, which can reference any method taking a string and returning nothing or void. Next, we instantiate the delegate by creating an instance and associating it with a specific method. The shorthand syntax, directly assigning the method name, is commonly used and achieves the same result. Once instantiated, you can invoke the delegate just like a regular method, passing in the required arguments. Alternatively, you can explicitly use the invoke method, which is functionally identical. Delegates are incredibly useful in Visual Studio for creating flexible and reusable code components, especially for callbacks. Callbacks are methods executed after an operation completes, allowing for asynchronous or event-driven programming patterns. Here, process complete callback is a delegate type matching the signature of onProcessComplete. The start process method in task processor takes this delegate as a parameter and invokes it after processing data. In the main method, we instantiate task processor and call start process, passing onProcessComplete as the callback. When executed, onProcessComplete receives the processed result, demonstrating the callback mechanism. Delegates are also the very foundation of event handling in C#, enabling objects to notify others when specific actions occur. We define data received event handler as a delegate type, and data received as an event based on this delegate within the data provider class. The data provider simulates data arrival and raises the data received event if there are any subscribers. The data consumer class subscribes to this event in its constructor using the plus equals operator, linking its onDataReceived method. When simulate data is called, the data consumer automatically receives the notification, printing the data. In Unity 3D, delegates are invaluable for creating modular and decoupled game systems, especially for event-driven programming. For custom events, the health class defines damage taken as a delegate and ondamage taken as an event. When take damage is called, the ondamage taken event is triggered, notifying any subscribers. The health bar class subscribes to player health.onDamage taken in its start method, linking to update health bar. This allows the health bar UI to update automatically whenever the player takes damage, without direct coupling. Delegates are also excellent for managing game states and triggering actions when the state changes. The game state manager defines game state changed as a delegate and onGameStateChanged as a static event. The setGameState method updates the current state and triggers the onGameStateChanged event. The UI manager subscribes to onGameStateChanged and uses a switch statement to update the UI based on the new state. This ensures that different UI elements are displayed correctly as the game transitions between states. Delegates can hold references to multiple methods, a feature known as multicasting, where all reference methods are invoked sequentially. We start by assigning method A to del, then use the plus equals operator to add method B to its invocation list. When del is invoked, both method A and method B are executed, printing their respective messages. Delegates can also be generic, allowing them to work with different data types while maintaining type safety. The calculate T delegate can be used with methods like add for integers and multiply for floats. We instantiate calculate, int, for add, and calculate, float, for multiply, and invoke them with appropriate arguments. Anonymous methods and lambda expressions offer a concise way to create inline code blocks directly assignable to delegates. An anonymous method uses the delegate keyword to define an inline block of code. Lambda expressions provide an even more compact syntax using the equals operator, making code more readable. By mastering delegates, you can write more dynamic, flexible, and maintainable code in both general C# applications and Unity 3D game development. Thank you for watching this beginner's guide to C# delegates. We hope this has provided a solid foundation for your programming journey.